Hello everyone, I'm Asraful Haq, the team leader of team Overfitters, and today I'm going to discuss our Smart India Hackathon problem statement. So our problem statement ID is HIH25198. The problem title is AI-based UFDR analysis tool. So what is UFDR? UFDR is a universal forensic extraction tool. And here's our theme is smart automation teams and it's under software category. So let's go into the problem statement. So here our project title is Detective X. So it's a detective forensic tool. So what it does, it's an AI assistant for investigating the officers to analyze the forensic reports, UFDR files. So basically it analyzes the UFDR files and give your query answers in natural languages. Like you can ask queries in natural languages, it will analyze the UFDR file and give you the answers, give you the answers with the evidences that found after analyzing the UFDR file. So the flow is like this: UFDR, you get the UFDR as input, our AI parses it and stores it in graph databases, sub-vector databases, and also some structured relational databases. And after this, there is a query engine running behind, and when you enter the query, the query engine processes the query, and it based on the our data is stored and some LLM agent AI agents, our query engine gets the result with the evidences and show you the report. So this is the thing. So let's dive into the technical approach. So for technical approach, we have implemented the front end in React and Tailwind CSS. And for backend, we used Fast API, and in AI layers, we used LangChain LLM, and like Gemini and GPT-4 we used for semantic search and understanding. And for databases we used for we basically use the three types of databases. For relational databases, for the structured data like the calls, messages, and media data that is under the UFTR file. And for ChromaDB we used for the vector embedding. We are using the RAG system for uh, in for the factual data, for storing the factual data so that we can query the natural language queries. And we are also using the Neo4j for knowledge graph or entities relationship. And entities knowledge graph is extracted the person's devices location. It's just mapping these things so that we can get the better results and correlations among the data, so that we can answer the complex queries. So these are the things. Here is all the problem workflow. You can see the workflow here: the UFDR ingestion, parsing and extraction, structured data. Some data are going into the structured data, and some are into the vector databases, and some entities relationship to build a knowledge graph. So here knowledge graph database is initializing, and here is the query engine workflow. You can see here the query engine submits the query, AI query engine parses it and retrieves the, or what it does, or AI query engine. First LLM, there is an LLM AI query engine. The LLM breaks down the query into the subqueries, and the subqueries task retrieves the information from these databases according to the needs. And then there is an aggregator, then aggregate and score the evidences based on our query. So it aggregates the data, relevant data, and score the evidences, and then our or summarize. Then there is a node, summarizer node, which takes the evidences, relevant evidences, summarizes the findings, and after this there is a highlight and key evidence. It highlights our data. So after this, our data are we prepare the report and send it to the front end for showing the report. So this is all the things. So here is the feasibility and viability. So you can see these are the most of the things we can see in the PPT. Here is the impacts and benefits. So there is a lots of impact. It's basically cutting the times of forensic from weeks to hours. So it's basically the main advantage is basic time. It's just cutting the time a very huge amount, and it reveals also the hidden results, and that would take a hidden relationships like results that may be a bit difficult for manual checking. as we are using the knowledge graph, so it's good for relating the things. So it's there is a lots of benefits, and there is also this are the research and references we have taken. So let's now dive into the prototypes. So let's see the prototype we have built. So here is our prototype. Here is the ingest UDF collection. You can see here we have to upload the UFDR file. It can also take the zip file, and here it supports this. It supports this format. So let's upload. Here I have a sample UFDR file prepared. So now let's open this. Now open and upload this. So it's selected, and now let's run the ingestion. So it will just go into the backend and process the ingestion agent. So it will initialize the database. So currently it happened in very quickly. So you can see it already extracted the some key concept like now how many contacts are there, number of messages in this file. So it's calls and locations, vector reports. These things are already stored here. So now let's run a query. So suppose we run a query for showing the foreign crypto messages after the 10 p.m. So the user maybe have talking to someone about the crypto in various apps like the WhatsApp, Telegram. The reports are in the UFDR file. So will be analyzing this, and we will be analyzing it and try to find how to get if there is any message crypto related after the 10 p.m. that user talks in the late night. So let's wait for the result. It will take a bit time, and it is analyzing the whole our databases and also using the uh, agentic reasoning for reasoning the agentic reasoning for finding the better result. So let's see, it's a given brief result. So what it says is on 2025 1912 and 10:05 clock, John Doe, the user, messaged a Bitcoin broker via WhatsApp regarding the conversion of the 12 BTC. So he want to convert the 12 Bitcoins. The timestamp of the effect, it is just telling about the timer in IST format. So it is evidence that it's a WhatsApp message, and here is the message that he sent. And now let's see, it also generates and summarized report. So here you can see it's a summarized report based on the evidences and the queries and all the findings that it had found. So key individual, it has also highlighted, you can see the highlighted like individuals, John Dew, Bitcoin broker, these things. It also analyzes, it's basically showing us how the results are got and based on evidence and evidences, and also some recommendation is there. So here is the complete report we found for this query. And suppose we want to export the query, export with the report that you got from here. So we can just export it in markdown file. It will be like this. If we save this, it will be downloaded. We can later on use this in other cases. So now let's move into some more interesting queries. So suppose I want to know uh, what are the foreign numbers that the user contacted? What are the foreign foreign numbers the user contacted? Contacted. So let's see what it gives. It's analyzing this. It will take a little bit of time, but it will definitely return something. It's analyzing the databases. So here you can see the result code based on the available distance. There is no foreign numbers contacted by the user. The current database, including the so it found no foreign numbers. Uh, you can see the it also gives the phone numbers like here. It's an Indian number. Most of the things. Current data set including the matches calls and no direct there's no direct matches between the foreign numbers direct contact, but it also highlights foreign numbers that the user may be in relationship the other way. Now let's get the things about crypto case. So let's see if there is any crypto case. Crypto case. Look or crypto crypto case. Okay, let's see if there is any crypto kit. We'll find it. So it's analyzing the database and it's processing the query in the backend. Basically, it takes time. So here you can see no explicit crypto case, and however a Bitcoin wallet address. He found a Bitcoin wallet address. Basically, there is a Bitcoin wallet address was communicated via Telegram by John Smith to Zondio. So John Smith, the thing is John Smith sent or user Zondio a crypto wallet address. So this is a thing. So here you can see the evidences, and here it generated the report. These are the things. So now let's ask about the John Smith. So what's the users? Who is John Smith? Is John. Okay, now let's ask a questions. Um, Name the person, the user frequently contacted, contacted. So let's see. It will just give the person that user frequently contacted via chats or calls. So it will analyze in the backend and give you the result. So it's analyzing the things. It's looking into probably it's looking into the relational databases or the chats, Postgres databases for the chats and our call records. So here you can see it's retrieved John Dew frequently contacted with John Smith. So we found that John Smith via all the John Smith was contacting in touch with the John Dew. So here's the five interaction with the messages and the two calls. So between it also give us the timeline between which the communication happened, and it also give us a summary about the things that happened between the interaction, summary of interaction between these two person. So here you can see the Bitcoin, the broker in Dubai. It also highlights these things, and it's also giving a report, this kind of things. So now let's see other things. Now let's ask a question. Does the user have a relation, have any connection with John Smith? John Smith or Jane Smith? Who is this? John Smith. Sorry, it's Jane Smith. Jane Smith. Jane Smith. Trace trace their interaction, trace their connection. So let's see what it does. It will just process the query in the background where the queries will be divided into the subqueries, and these subqueries will individually perform some task on the databases. Our vector databases, we have vector databases, a relational database for Postgres structured data, and there is also a knowledge graph. Here you can see it's using the graph insights here. The knowledge graph, Zondio connects to the message 1, message 2, message 3. It basically connects with the Zondio with the message 1, message 2, and James Smith connect to the message 2. So it gives us the interaction. Then the message 2, message 4, and call 2 happen between the transfer and Zondio. So broker Bitcoin, he's also involved in Rajesh and this kind of things. You can see yes, Swansmith was a connection with the non-due is connected to the message one, which directly links with the James bit. Message one, this kind of thing. It's just showing the relationship, drawing the relationship between the two persons. So here you can see a summary that generated based on the evidences and our queries. So basically these are all for our things. Thank you for watching. And here we are team overfeeders. So let's wrap this up and share all the things. I think I have mentioned all the things. Thank you for watching.